Hello, welcome. Let's work through the problems assigned out of section 5.2. First up, the function f of x equals x cubed plus 8 is 1 to 1. Okay, this is simply a given bit of information. We don't need to establish this or explain why. It's just given to us. The function is 1 to 1, which means it has an inverse. So in part A, we are asked to find it. Then in part B, find the domain and range of both f and f inverse. So to find the inverse of a function, we start with y equals x cubed plus 8. This is the original function. The inverse merely swaps the role of x and y. Input and output get reversed. So instead of y equals x cubed plus 8, we'll have x equals y cubed plus 8. This will be the inverse. Now all we have to do is solve this for y. Well, if we have y cubed plus 8 is equal to x, I've merely reversed right and left. I can subtract 8 from both sides, and then I can take the cube root. So here is our inverse function. So for part A, I can say f inverse of x is the cube root of x minus 8. If you prefer, you can call this x minus 8 to the 1/3 power. Just as good. So, to find the domain and range of both f and f inverse, the thing to remember is that the domain of f is the range of f inverse, and the range of f is the domain of f inverse. So it looks like this problem is asking us to find four things: the domain of f, the range of f, the domain of f inverse, the range of f inverse. But because the domain of f is the range of f inverse, and the range of f is the domain of f inverse, we're really only asked to find two things, and in general, domains are much easier to find than ranges. So what's the domain of f? Well, f of x was x cubed plus 8. It's a polynomial, so the domain is all reals, which means the range of f inverse is also all reals, because the domain of f is the same as the range of f inverse. Okay. Now suppose we now want to find the range of f. Finding the range of a function is actually not that easy to do directly. However, let's instead find the domain of f inverse. Okay. Now f inverse is a cube root. If this was a square root, I would be concerned that the thing I'm taking a square root of is not allowed to be negative. We don't have complex variables floating around. However, cube roots do not have that obstruction. You can take the cube root of a positive number, you can take the cube root of a negative number. And x minus 8, there's no obstruction there. No matter what x is, I can subtract 8 from it. Whether the result is positive or negative, I can take a cube root. So the domain of f inverse is all reals, which means the range of f is all reals. Okay. Depending on how exactly you have studied polynomials, you could also observe f of x is a polynomial of odd degree. Polynomials of odd degree always have a range of all real numbers. So if you observed that f of x, x cubed plus 8, is a polynomial of odd degree, the degree is 3, you could immediately say the range of f is all real numbers, and then you would immediately know that the domain of f inverse was also all real numbers. Okay, so again, we're given a function we are told that is 1 to 1, and very similarly, find the inverse, and then find the domain and range. So instead of starting off with y is 1 over x minus 10, we swap and say x is 1 over y minus 10. So this is the original, and this will be the inverse. Now we just need to solve this for y. So if I multiply both sides by y minus 10, we get this, and now I can divide both sides by x, and then I can add 10 to get f inverse is 1 over x plus 10. Okay, we can check to make sure that this is correct. The way we would check this is we would say, what's the composition f of f inverse of x, and also what's the composition f inverse of f of x? Okay. When you compose a function with its inverse, f of f inverse and f inverse of f should, at the end of the day, just produce x. So let's see what happens. This is going to be f of f inverse of x, which is 1 over x plus 10. Okay. Now what does f of x say to do? It says do 1 over the input minus 10. Now in the denominator I have a plus 10 minus 10. Those cancel out, and we have 1 over x, which is just x. So we see that indeed the composition of f with its inverse, whatever you plug in is exactly what you get out. We can also check it in the other order. So this would be f inverse of f of x, which is 1 over x minus 10. What does f inverse say? It says take what your input was and reciprocate it and then add 10. But 1 over x minus 10 is just x minus 10. Then the 10 and the minus 10 cancel out and you just have an x. So again, if you plug x into this composition, you get out exactly what you plugged in. So they are indeed inverse functions. We were probably asked to do this in the last problem, I just neglected to do so. Okay, but again, we are asked to check the domain and range of both f and its inverse. And as before, this is not really 4 different problems, it's really just 2. And as before, domains are typically easier to find than ranges. So what is the domain of f? Since f of x is 1 over x minus 10, we need the denominator to not be equal to 0. In other words, it's all x's that are not 10. If that's the domain of f, it is also the range of f inverse. Y can't be 10. Remember, in the range, we're talking about y values. So we've already done the work. It's everything other than 10. Okay, the domain of f inverse is pretty direct to find. Since f inverse has 1 over x and then you add 10, we just need that denominator to not be 0. And that means that the range of f is everything except for 0, but we would talk about the range of f in terms of its y values. All right, same problem as before. We've just got a slightly more complicated function going on here. But we're going to proceed exactly as we've been doing. Okay, so we begin by swapping the role of x and y. So we would say x is equal to 6y over y plus 7. And now we need to solve this for y. Okay, a good place to start is to clear out denominators. So if I multiply both sides by y plus 7, we get this. Now I've got y's on both sides of the equal sign, and I want to solve for y. So a good place to start is to get all of your y's on one side and everything that doesn't have a y on the other. Okay, so I'm going to move, for example, all of my y's over to the right. So I'm going to have 6x is equal to 6y minus xy. Notice that I can now factor a y out of this side. Now if I divide both sides by 6 minus x, we'll get 7x over 6 minus x is equal to y, and we've solved for y. So this is f inverse. I'm just going to write it up here so that I don't accidentally erase it. Now let's check. If I compose f with its inverse, I should just get out x. And let's see what happens. This is going to be f inverse of x is 7x over 6 minus x. Then what does f of x say to do? Okay, it says take your input and multiply it by 6, then divide by your input plus 7. Now this looks like a lot, but the reason it looks so bad is that I have fractions within fractions. And we can simplify this a great deal if I simply multiply the numerator and denominator by 6 minus x. Notice all I've done is multiply by 1. This is a totally allowable step. But what this has the effect of doing is it cancels this denominator here. And if I am careful about distributing in that denominator, okay, my numerator just becomes 42x, and my denominator becomes 7x over 6 minus x times 6 minus x plus 7 times 6 minus x. Now this 6 minus x cancels that one. So what we have is 7x plus 42 minus 7x. 7x and negative 7x in the denominator cancel, leaving behind 42x over 42. 42 cancels 42, and we just get x. Okay, we can also compose, instead of f of f inverse, we can compose f inverse of f. Now, depending on the expectations in your particular course, when you're asked to check your answer in a problem like this, you might only have to do it in one order, or maybe you're expected to do it in both, but just for the sake of practice, we're going to go ahead and do it in both orders. So since we've done f of f inverse, now we're going to move on and do f inverse of f. Well, f of x was 6x over x plus 7. What does f inverse do? Okay, looking in the upper right, it says take your input and multiply it by 7, then divide by 6 minus your input. And similarly, this looks bad because there are fractions within fractions. So if I multiply by x plus 7 over x plus 7, what's going to happen in the numerator is these are going to cancel out. And in the denominator, we just have to be a little careful. But my numerator is now 42x. The denominator of x plus 7 exactly canceled. My denominator is 6 times x plus 7 minus 6x over x plus 7 times x plus 7. Actually, I'm going to not try to fit it down here, but rather up here. All right, now what we have to do is observe what happens in that denominator, and we already know what we're hoping will happen. If everything has worked out just fine, at the end I should just have an x. It's always nice in a problem like this to know where you're trying to get. Okay, so our numerator is still just 42x. Then down below we've got 6x plus 42. These x plus 7's cancel, and I just have a minus 6x. My 6x and my minus 6 cancel out, so we have 42x over 42. 42's cancel, and indeed, this just equals x. Okay. So as I mentioned, depending on what's expected of you in your particular course, you may only have to do one order of composition to verify a function that you found the inverse correctly, or you may be expected to do both. As long as we're just practicing, I don't see the harm in just doing both. Okay, we're not quite done with this problem. We are asked to find the domain and range of both f and f inverse. And once again, the domain of f is the same as the range of f inverse, once we account for what's called x and what is called y. So the domain of f equals the range of f inverse once we account for variable names. So the domain of f, well, f of x is 6x plus 7. The only obstruction here to being in the domain is I don't want my denominator to be 0. So it's all x that are not equal to minus 7. This means the range of f inverse is all y except for minus 7. Remember, inverses just swap the role of x and y, but otherwise the domain of f is the same as the range of f inverse. Similarly, if I was trying to find the range of f, what I would really do is say, what is the domain of f inverse? Well, f inverse is another rational function here, 7x over 6 minus x. The only obstruction is we don't want the denominator to be 0. In other words, x shouldn't equal 6, which means the range of f is all y other than 6. Same as before. All right. So we swap the role of x and y to find an inverse, and we end up with x is equal to 8y plus 9 over 7y minus 8. Cross multiplying, or multiplying both sides by 7y minus 8, is going to give us this. And our goal is now to solve for 9. That's a y, I apologize. So let's distribute out this left side. 7xy minus 8x equals 8y plus 9. Let's get all of our y's over on one side and all of our not y's over on the other. Okay, so our left-hand side could be 7xy minus 8y, and our right-hand side 9 plus 8x. Now I can factor a y out of the left. That was nice that it worked out. This is a general technique that will work for rational functions where both numerator and denominator have degree 0 or 1. So we have a rational function for f of x. The numerator has degree 1, the denominator has degree 1. As long as you don't have degree 2 or larger in these rational functions, this is always going to work more or less the same way. Now I can divide both sides by 7x minus 8, I apologize, leaving this. And here is our f inverse of x. To check that we have actually found this correctly, okay, we just need to compose f with f inverse or f inverse with f. We've done this several times now, so in the interest of time, I'm not going to do both. We'll just do one. Okay, so let's go ahead and check. Let's just do this order, f composed with f inverse. So this means f of f inverse of x. We just found a candidate for f inverse of x to be 9 plus 8x over 7x minus 8. The function f says, now this is going to take some writing, do 8 times your input plus 9 divided by 7 times your input minus 8. I've got fractions within fractions, so let's try to simplify that a little bit. I'm going to multiply the numerator by 7x minus 8, which means I better also multiply the denominator by 7x minus 8. I just need to be careful about distributing properly here. So what we get is 9 plus 8x over 7x minus 8 times 7x minus 8 plus 9 times 7x minus 8 over 7 times the quantity 9 plus 8x over 7x minus 8 times 7x minus 8 minus 8 times the quantity 7x minus 8. Now the good news is this denominator cancels that, this denominator cancels that. Now all we have to do is distribute everything in the numerator and denominator and hope for the best. Okay, I actually don't want to erase this thing in the box because we are going to need it for part 2 of this problem. So let's just come back over here. All right, 8 times 9 is 72 plus 64x plus 63x minus 72 over 7 times 9 is 63 plus 56x minus 56x plus 64. In the numerator, 72 and negative 72 cancel out, and in the denominator, 56x and minus 56x cancel. So finally, what we have in the numerator is 127x, and in the denominator, we have 127. $127's cancel, and just x, which is what we wanted. Okay. We could go ahead and do this in the other order, but it should proceed more or less identically to this one. So rather than do all the same work more or less again, we're just going to move on and go to part B, find the domain and range. Okay. So the domain of f, well, f is this rational function up at the top, 8x plus 9 over 7x minus 8. So we just need to make sure that denominator isn't 0. In other words, 7x can't equal 8, or x can't equal 8 over 7. And that just means that the range of f inverse is all y's except for 8/7. Similarly, the domain, sorry, my hand slipped there. The domain of f inverse, well, f inverse is this rational function with denominator 7x minus 8. So we want to make sure that its denominator is not 0. But observe, that's actually exactly what we did to find the domain of f. So this is going to proceed exactly the same way. X can't be 8/7, which means the range of f is all y's other than 8/7. It was a coincidence in this problem that the single forbidden value for the domain of f was also the single forbidden value for f inverse. It happens to deal with the fact that 8 times 8 minus 9 times 7 is exactly 1, but that's not here nor there at this point. Moving on.